now. Okay, so number one, there's one thing. I moved the workout. Is anybody going to do the workout with me? I did move it to tomorrow because people have track practice. You're going to do it with me? Yeah? Oh, I am so pumped. All right, it's going to be awesome. You have no idea how excited I am. I have it ready. You don't really need weights, but if you have them, there might be an extra exercise I might make us do with them. But otherwise, it's all body weight exercise stuff. So, and it's going to be like a Tabata workout where you do 30 seconds on, 15 seconds off, 30 seconds on, 15 seconds off. And we're going to do like the same exercise 5 times through, and then we get a minute break, and then we go on to the next exercise and stuff like that. So it's pretty awesome. So whoever's joining me, again, can I have a show of hands again? Who I'm going to see tomorrow at 2 o'clock? 1, 2, 3. You have no idea how excited Mama Schwa is, okay? Yes. All right. All right, that's one. Number 2, like I said, this class we're going to be, make sure you have your calculators and all your stuff ready to go. Today's class, I want to talk about regular polygons inscribed in a circle and finding isolated regions. And a regular polygon is a polygon where all sides and angles are equal. So we're going to spend time on that today, and then we're going to do more review tomorrow. So we're going to do more review tomorrow because on Monday is when your assessment is. And here's how it's going to work. Based on your last name, like I'm going to have 8 problems. And based on your last name, like if your last name starts with A through G, you guys are going to do problems 1 and 2. Anybody whose last names are like H through L, you guys are going to do problems 3 and 4 and so forth. So it's going to be one of those things that's going to happen. Okay. So just give me 1 second. And that's how we're going to do it. And it's all going to be uploaded on Canvas. So you're going to do everything in front of me. You're going to take a picture of your work. You're going to upload it to Canvas. And when you're done, you can go. Okay. So that's pretty much how, all of that stuff is going to roll. So just give me 1 second to get this going. Okay. Class has started.
Hello.
Hi.
Sorry, I was grabbing my flow of food and I just had a meeting.
Okay. What are you noshing on?
I just finished a protein shake and I have waffles.
You have what?
More pancakes. Waffles and pancakes.
Well, that's nice. Are you like a butter and syrup person like I am? Because I'd rather do butter more than I would syrup, to be quite honest. I think butter is delicious. Who is a fan of butter? Can I have thumbs up for people who love butter? Because I think butter's awesome. No, I guess you guys are more syrupy people, huh? You mushies. All right.
Mm-hmm.
Okay. Okay. So we're going to get started here. Nothing like the present to get started. If this does run late and you have to go, that's okay. You can always go back and watch what we have to do here. So the first things first is it says to find the area of the shaded region given the inscribed regular octagon. Okay. So just hypothetically, let's take a look at what we're given. Okay. So if you notice, I have to turn this on. I only have 4 pieces that are shaded, right? I only have this piece, this piece, this piece, and that piece. And it's like pieces of crust, if you will, right? But what if I had them all shaded? What if they were all shaded? You know, how would I go about finding, let's say I shaded orange here. You know, hypothetically, how would I go about finding the area of all 8 pieces of? And I'm going to start with Morrison. What do you think we should do here? What are some things we need to find? So Morrison, you're the first one up because that's the first name I saw on my list.
Maybe the area of the entire circle.
Okay, we want to get the area of the circle. I love it. And then what else do you think we're going to have to find? So we definitely need to find the area of the circle. Is there something else we should probably find?
Can we make it like a triangle?
Yes, we can. But my thing is, let's just go conceptually right now. We're going to do all that juicy math in a little while. But like you said, we're going to find the area of the circle first. But then to get these pieces around that are shaded, what do I have to subtract out?
The area of the shape in the middle.
What's that shape called? It's 8 sides.
Octagon.
Yes. So and absolutely 100%. So we got to find the area of the circle, and we have to subtract out the area of the octagon. Can I get a thumbs up for those of you who agree? Awesome. So is it easy, by the way, is it going to be easy to find the area of the circle, Maeve? Is it going to be easy to find the area of the circle?
Yes, because they gave you the radius.
Yeah, we have the radius. Isn't that beautiful? So the area of the circle is, everybody, pi times your radius squared.
R squared.
Yep, so it's pi r squared. So we're going to do pi times 32 squared, and that is going to be 1024 pi. Okay. All right, so that's going to be 1024 pi. And that's and I want to leave it in terms of pi, because if we multiply pi out, it's going to be a decimal, and I want to get as close to the exact area as possible. So do we all agree that the area of the whole circle is going to be, I'm going to put the circle here, is 1024 pi. Good. So now we're jumping onto the area of the octagon, right? So the area of the octagon, now Morrison, you said, can we break it down into?
Triangles.
Yes, the answer is yes. And we can totally break it down into triangles. So we can just go about doing it like so, all right? And how many of you are actually drawing this, by the way? How many of you are actually drawing this? Good. So what I'm gonna do, so for you guys, if you're like, how do I draw this so that it looks semi-decent? Real quick, you're just gonna do 1, 2, draw a circle, 3, 4, 5, 6, 7, 8. Just draw, try to equally space them around the circle, and then just play connect the dots, la, 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 connect the dots, la, 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 la. Okay, so if that's how you're trying to do it, you're gonna do it that way, and then we just break it down into 8 triangles, okay? So for those of you who just showed up, it's nice to see you. What we're doing is we're trying to figure out areas of shaded regions. So the first thing we did is some of us are drawing this as we found the area of the whole circle, and we know that it's pi r squared and the radius is 32. And then Morrison said we got to subtract out the area of the octagon to get the area of the purple and orange pieces. So now, what kind of triangles are these? Rachel.
These are equilateral triangles?
So if they were to be equilateral triangles, that means all of the angles would add up to how much, or the measure of each angle would be what?
180?
Well, they would sum up to 180, but if it's equilateral, it would be the measure of each angle.
Oh, they all equal 60?
Yeah.
All equal 60.
So now let's go over here. So here, there's a couple of things that I wanna point out, right? So if I asked you guys to get me the measures of the angles in the center of the circle, how would we go about finding the measures of the angles in the center of the circle? Baskin, what would I do?
I'd have to, give me a sec.
Well, if I want to find the measure of each of these angles in the center, what do you think I would do? First of all, what do I know about their sum?
What do we know about the side is 32 inches?
The side, no, I didn't say no. The sum of the angles in the center.
Oh, the sum of the angles, they all equal 360
They
degrees.
do. So how am I going to find the measure of each one?
You just divide 360 by 8.
You sure do, my friend. I believe we get 45 degrees. Does everybody agree with that? We're getting 45 degrees for that. That was awesome, Andrew. So I know then that these are all 45 degrees, 45 degrees, 45 degrees. And then if this is 32, Nina, what's this going to be over here? What's the length of this segment here?
Wouldn't it be 32 as well?
Yes, why? You're right, 100%.
Because they're all equal
Because they're all what?
radius.
Yes, they're all radii. Very good. So now, Rachel, getting back to you, these are not equilateral triangles, but they are in fact what?
Scalene triangles?
No. The other one. You're finally going to get to it.
I don't know what it's called. I forgot what it's
Starts
called.
with an I, Sparkles.
What?
Starts with an I.
Isosceles triangles.
Got it, girl. See, I knew it would come. I knew it was in there. Okay. So I'm taking one of those triangles. So this represents, like, let's say, for example, this triangle right here, okay? So everybody, so if I want to find the area of the octagon, okay? So if I want to find the area of the octagon, I can find the area of this triangle and then do what, Alex Leon? I can find the area of this triangle, and then if I want the area of the octagon, what would I do with that?
Multiply it by 8.
You sure would. Okay, so now I want to find the area of this triangle. So what's the first thing I have to do here? Karia, what's the area of a triangle anyway?
1/2 base times height.
It is 1/2 base times height, neither of which I have. By the way, I have a base drawn in, but I don't have what yet?
The height.
You don't have the height yet, so we got to draw in the height. So if I draw in the height, it's going to create 90 degrees, 90 degrees. What's going to happen to this angle over here, Aiden?
It would bisect.
It would bisect it, good. So that's going to be 22.5, and that's going to be 22.5, right? So now, if I want to find it, does everybody see I could take an isosceles triangle and always break it down into 2 equal right triangles? Yay or nay? For those of you who say yay. Okay. So Katie Kim, as I'm going to take one of those right triangles. So this triangle here represents this triangle over here. Are you with me?
Yep.
Okay. So this is 22.5 here. This is 32 here. Would you agree, like, what do you want to call this side, kiddo? What do you want to call it?
Oh, wait.
Call it anything you want. You have 26 letters of the alphabet.
H.
Sure. What do you want to call this side?
O.
Oh, it is. Okay. So, based on what Katie decided to call these, right, you agree that this is O here and that this is H right there. Is everybody saying that this triangle here corresponds to that one? If your last name starts with an A through J, you guys are to find O. Anybody from K through Z, you're going to find H. Ooh, I got a tickle. So Leah's here, Ryan's here. Both of my Alexes are here. Both of my Maddies are here. Awesome. Now, if you're asked to find O and you're done, go get H. Okay? Is that somebody's dog?
Yeah. It's mine.
Okay, who has O? I'm going to call out. Nick G, do you have O, kiddo?
I got 29.56 for O.
29 point what, hon?
5.6.
Okay. And can I have H, please? Taylor.
I got 0.01.
Does that make sense? Yes or no? Does that make sense?
No.
No. Okay, so let's talk about it. So can you give me the equation you used to find out what H was?
I used sine
Me too. Good. So you did the sine of
22.5
equal to.
equals x over 32.
Okay. And then
Well,
did you
just
multiply
remember-
32 times 22.5, the sine of 22.5?
Yeah, I accidentally divided it.
Ah, okay. So be careful because remember, you're just going to cross multiply. So just tell me what you get for h now. And does everybody realize that h represents half of the whole base? Does everybody see that h represents it? So Taylor, do you have a kid?
Yeah, 12.25.
That sounds more feasible. Does everybody get 12.25?
Yeah.
Okay. So this is 12.25, which means this is also 12.25. So my entire base looks like it's 24.5. Is that fair?
Yes.
Okay. So now if I want the area of this triangle right over here, the area of that triangle is going to be 1/2 times my base, which is 24.5, right? Times my height, which is 29.56. Does everybody agree that this length here is the same thing as that length right there? Is everybody okay with that? Those two are the same length. All right. Who has the area of one triangle for me? Rebecca, do you have the area of one triangle, honey?
It's 300. Well, I also did 12.48, but it's going to be close to it. I got 361.81.
361.81.
Wait,
Yeah.
I got 362.99.
Yeah, it's all about how you guys round. It's how good of rounders you are. So if you're just doing the sine of 22.5, let all that decimal play out. So that way you get that giant decimal and just multiply that answer times 32. And that should be a better, approximation of what the actual value is. So just be careful when you guys are doing your trig stuff, okay? So I see 362. We're going to go with 362.11 just based on these numbers that I have down here, okay? So that's 362.11. That takes care of one triangle. How many do we have, everybody? We have 8 of them, yeah? Because this takes care of, because this triangle here, this whole triangle here is that triangle right there. Are we okay with that? Say yes, 362.11. So I have to multiply that by 8. And then if I multiply that by 8, we should have 2896.88. Is everybody okay with that? Hello, is that on?
Yeah.
Okay. So now let's go back. We found the area of the circle, but in order for us to find the area of the octagon, we broke it down into triangles because we know how to find the area of a triangle. We know we can use trigonometry, so we have all of those fabulous tools that we can use in order to find out what the area of the octagon is, which we did find. So now if I want the area of all 8 of those pieces of crust going around a circle, you're just going to take the area of the circle, you're going to subtract out the area of the octagon, right? And I believe that gives us, did you guys get 320.11? Hello? Is equal to 320.11. So does everybody agree if I subtract those two, that's how I got it, that it takes care of all 8 pieces, yes? So if you guys, yes, thank you for verifying that. Now, at the beginning of this, though, you'll notice I only had 4 of those pieces highlighted. So if I only had 4 of those pieces highlighted, what am I going to do to this area, Zach?
Me? Did you say Zach?
Yeah, you're the only Zach we have.
Oh, it's kind of like bluffering. Do you divide that by 4 or multiply by 4?
Well,
I
this
think-
represents, remember, this represents the area of all 8 pieces. Yes?
So
if I
you,
divide all,
yeah.
all 8 pieces combined together is 320.11. Can somebody mute their thing? That the back stuff I'm getting is killing me. So, Zach, how much is the yellow?
Yeah, you divide by 4.
No,
No, you wouldn't divide it by 4 because this
you
represents.
do it.
Because here's my thing, you're not going to divide it by 4 because the yellow pieces represents how much of all of the pieces.
The yellow represents half.
So you're going to take this and divide it by 2 to get just the yellow pieces.
Oh,
You see what I'm saying? Right?
yeah.
Okay. So now I'm going to throw a bogey at all you beautiful people. Whoops, that's not what I wanted to do. So now let's say, for example, that I have those pieces, right? Because I have the total area of all 8 pieces. Yes? What if I want 5 of them? How would I figure out just 5 of those pieces? Can you guys figure out a way to tell me if I just wanted 5 pieces, if I know the total area of all 8 is 320.11, so that's all 8 pieces, how would I figure out the area of just 5 of them?
Wait, Seychelle, I have a question.
Yeah? I'm listening. Hello? Who had the question? Did I lose somebody? Okay, so Dylan, how am I going to get the area of those 5 pieces?
So I think that if you have 8 at the start,
Uh-huh.
and you divide in half by, if you divide the 8 in half to get 4, and then you divide the 4 in half to get 2, and then you divide the 2 in half to get 1.
Whoa, whoa,
Like
whoa.
you get the value of 1 piece.
No, okay, so if you wanted to get the value of 1 piece, all you have to do is take the 320 and do what?
Divided by 8.
Yeah, so if you divide that by 8, what do you get when you take that and divide that by 8? I think you get 40.01, is that right?
40, yeah.
Yeah, so in other words, so you're saying take it, and so now you know each piece represents 40.01, yes?
Yeah.
So that's, and I think that's brilliant, right? And then now all you have to do is multiply that answer by?
5.
By 5. So you're just gonna do 40.01 times 5. Rebecca, I see your hand up. What do you got, kid?
Well, can't you also just take 320.11 and divide by 5/8?
Well, not divide by 5/8, but
Well, it would be multiplied by 8/5, and you get the same answer.
yes, you can totally do that. Yes, because you're doing 5/8 of the whole thing, right? Good, I love it. So is everybody clear on that? So you can, isn't it nice that there's more than one way to do something? You know how I love that. Okay. Who's trying to connect? Someone's trying to connect. I must have lost somebody. So whoever that is, we'll try to get them in here. Okay. So I'm going to go to the next one. All right. So you guys are going to get started on this. If anybody has to leave, you can leave, but you'll have to finish watching. But I want to see what you guys do based on what we did on the previous problem. You want to get the area of that shaded region. So I want to know what you guys are going to do to attack this one. And I'm just going to sit back and watch you. In about 5 minutes, I'm going to see how far we got. Okay. So again, we want the area. Yeah, honey.
Sorry, I cut out when I had a question.
Yep.
But for the last problem, like, what did you subtract to get the 320.11 for the area?
Okay, so what I'm going to show you is going back here. The area of my circle was 1024.11, right? That was the area of the whole circle. And the area of the octagon was 2896.88. So when I subtract those two, it gives me the area of all 8 pieces.
Oh, okay.
Does that make sense?
Yeah.
Okay. All right.
Thank
you. Good. So now we're going on to this next one. And again, like you guys, like I said before, if you want to draw this, draw a circle and try to space 5 points around the circle equally and then play connect the dots. And then I want to see how far you guys get. Okay? Rachel?
Seychelle, I have to go, but I'll finish watching the video. Okay.
We have until 26 though, so you have 3 minutes. So I want to see how far you get. Okay? So Rachel, before you leave us, can you tell me what was one of the first things you did to attack this problem?
The first thing I actually did was try to find the area of the Pentagon instead of the circle. I just did that first.
So what did you do first? So tell me what you did.
I divided 360 by 5 to get the inner angles of each triangle.
So before you did that, the first thing you did was break this into 5 triangles first. Is that what you're telling me? Okay, so start there. All right, so you broke it into 5 triangles for starters. Awesome. So you said with the area of the Pentagon first. Okay.
And then I found the inner angle. The inner angle of each of the triangles by dividing 360 by 5.
Center angles. You sound much better.
What?
Say the central angles.
Are the central angles, the triangles, by dividing 360 by 5, which equals 72 degrees.
You got it, kiddo.
And then I was gonna find the height of each triangle, and that's as far as I got.
Well, what do you know about the bases of all the triangles, honey?
Each base is 15 centimeters.
That's amazing. Okay, you know what? I'm gonna leave it there. I think you got us off to a phenomenal start, right? Because you said you're taking one of your triangles, right?
Yeah.
And you said that's 15. And you said, what's one of the first things you're going to do before I say get out of here? Did you drop an altitude?
Yeah, I'm going to find the height of each triangle by dropping an altitude.
And what does it make each one of these angles?
It makes each one of those, I didn't divide it yet. It equals 36 degrees. Yeah.
Awesome. You have a great day, and because you said you're going to find H now, because that's what you wanted to get, right? So Rachel's saying, I want to get my hands on H, right? What do you know about, before I even let you go one more time, what are the measures of each one of these 2 pieces?
Each one of those pieces equals 7.5 centimeters now.
You have to watch the rest of this, okay? You got us off to a fabulous start, so thank you.
Thank you. Bye.
All right, honey, have a good day.
Thanks.
Okay.
See, Schwab.
Yeah, hun.
I have to go too.
Me too.
Okay, whoever has to go, you go ahead. You are responsible for
I have to go in like 2 minutes.
Bye.
get it through as much as you can. And then,
Alright.
you know, whenever you have to go, okay? But you are responsible for watching this, okay?
All right.
Bye, hun. All right, so for those of you who are hanging in there with me, there's quite a few of you here still, which is awesome. Okay, so I'm going to be calling on you because I'm seeing all those beautiful faces. So just be ready. Then, you know, Mama Schwa's going to call on you. So get ready because there's some of you I haven't even said hello to yet. Hold on, hey guys, are working away, worky schmirky, working away. Okay, so who has H? Leah, what do you have for H, honey?
I got 12.76.
Does everybody agree it's 12.76 for H? I don't know about that. This guy here, the height?
I
Huh?
got that for the side, but I got.
What do you mean this right over here? You got that?
Oh, I meant 10.32.
Okay, thank you. Yes. So this is 10.32 for H, right? And we got H by doing the, looks like the tangent. Right? The tangent. So we did the tangent of 36 is equal to 7.5 over H, right? And then I am going to go find that side because We'll find out why we need that in a second. So we get 10.32. So before Rachel left, she said she wanted to get her hands on the area of the Pentagon. So Alex, Leon, she can get the area of the Pentagon now, can't she?
Yeah.
Yeah, so what are we going to do to get the area of the Pentagon, kiddo?
You're gonna multiply the base and height and divide it by 2.
And then multiply that by?
5.
You got it. Okay. So we're going to do 15 times 10.32, right? And then actually I'm just going to do times 5. I'm just going to say the whole, watch this. Watch this. I'm going to change this shape to a pentagon. All right. Katie Kim, what do you have for the area of the Pentagon, honey?
I'm doing it right now.
Okay, honey.
I got 387.
387? Yes.
Yeah.
I did too. I remember I got it. 387 from the class. Now, so we got the area of the Pentagon, right? Deja, what do we now have to get the area of? So we got the area of the whole Pentagon. We got that, which is great. But now what do we have to get our hands on?
The circle?
Yeah. So we have to get the area of the circle. In order for us to find the area of the circle, what do we have to find?
The radius?
Yeah, we need the radius. Now, the radius is the same thing as what in this triangle?
The hypotenuse.
It's the hypotenuse. Good, because this is this, right? This is the x that we're talking about. So if we want to find out what x is, right, we're going to do another tangent, not a tangent, we're doing the trig thing where we have the opposite over the hypotenuse. So I think we're going to use the sine for that, right? So it's going to be the sine of 36 degrees is equal to 7.5 over x. And that's, Leah, you said was 12.32?
12.76.
That was not 3.2, it was 7.6. Oops. Okay, so we got 12.76, thank you, honey, for our radius. So that's equal to 12.76. Let's see, Elliot, can you get me now the area of the circle?
Yeah.
So it's going to be pi times?
Pi times 162.82.
Exactly. So it's going to be, so we'll just do 12.76, right? Squared, whoops. 12.76 squared times pi, right? We may as well just multiply that out. So that I see 511, area of the circle is equal to 511.51. Yeah. So that takes care of the area of the circle. We have the area of the Pentagon. What are we going to do to those two things, Karia? Subtract them, yes. So we're going to subtract that. So we're going to subtract that from that. So that means I'm going to get the area. So if I do the area of the circle minus the area of the Pentagon, I get 124.51. Whoops. What is the 124.51 actually represent? Let me see if I can say hi to some other people. Sophia, what is that 124.51 actually? Get out of the way.
The area of each triangle?
No, because let's see. Let me move this out of the way. Are you sure? Because let's take a look at where I got my 124.51 from, right? We found the area of the circle and we found the area of the Pentagon, right? This was the area of the Pentagon, and the Pentagon we found by finding the area of all 5 triangles. Yes?
Oh, is it the like the shaded region per?
Well, the 124.51 represents how many pieces of area. That's a way that I can say it. How many pieces of area are we talking about?
5.
5, yes. All 5. So in other words, this right here, this 124.5 represents this, 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 and that. So it's all 5 pieces, right? I only want 3 of them. I only want 3. So Dylan, how am I going to go about getting my 3?
You could take the total and then divide it by 5, and then you could just take that number and multiply it by 3.
Love it. Okay, so we're going to divide that by 5, and we get 24.91. So each one of these represents 24.91. right? So 24.91. I only need 3 of them. So if I multiply 24.91 times 3, I am in happiness world.
74.71.
74.71. Wasn't that a delicious problem? Wasn't that delicious? And if you think about it, was there anything you knuckleheads didn't know? No, isn't that, yes, Dillies?
I just have a question.
I have
If
so many more.
I originally rounded mine to 12.8 and my final answer was 76.63.
Isn't that amazing? Remember, Schwa likes 100th place, so just always go with 100th place when you're doing your final rounding, so we'll all be as close as possible, okay? But other than that, I think you're good. I think, how many of you like, these are kind of nice problems, and you think you might see them on Monday? You think you might see these on Monday?
Yeah.
Probably.
Yeah, you know you will. So in addition to that, so tomorrow you're going to bring all of your other stuff with you to class. You're going to bring all of your other, I guess Elliot got kicked out. You're going to bring all of your other stuff to class, and then we're going to go over those other area problems. And then, like I said, on Monday, you guys are going to be assigned a certain 2 problems based on your last name, okay? So bring your A game, and then for those of you who said you're working out with me, I'm pumped. All right, we're gonna have a good workout tomorrow. So those of you who were thinking about it, I don't care, just do it anyway. Come, all right?